Okay, this is 8.2 homework. The first problem gives us this triangle. I made it a little bit bigger here, and it wants us to find the value of x. So we're going to use the law of cosines. Now I'm going to write the law of cosines like this. A squared equals b squared plus c squared minus 2bc cosine of angle A. You can write it however you want, but keep in mind that the side you're using here, or the side you're looking for, the angle opposite that goes here, and the other two sides go here, and here. So this is the way to write it in this case, because angle A is what I have, which is 39. So I'm going to plug everything in for you like this, and then I'm going to take the square root of both sides, and that gives me what I'm looking for, which is x. You can plug this whole thing into your calculator just the way it is, as long as you're in degree mode. So let me do that. Just like that, and then it's not hard to enter that in, because the calculator will follow order of operations. So 28.88 is my answer. But the calculator will do this squared, and then it'll do all this multiplication in the right order. All right, the next problem is similar. I'm going to write it now for b. So I'll do b squared, and then I'll do a squared and c squared here. Cosine of angle b. So let me plug everything in for you in this case. All right, so it's plugged all in. This is our x now. So this time we're solving for this right here. So I'm going to have to subtract both of these two things over, and I'm going to have to divide by this quantity here after I've done that. And then I'm going to have to take the inverse cosine. So those are all things I'm going to have to do in the calculator. I'm going to show you the steps here in the calculator. So first I'm going to subtract these over like I did here. I'm going to hit enter there. And then I'm going to take this number and divide by this number right here. So let me do that now. And don't forget to put that quantity in parentheses right here as well. This whole quantity right there. And then that gives you negative 0.867. Now take the inverse cosine of that. And that will give you your answer of 150.11. Actually, I made a mistake and forgot that negative sign right there. When you divide both sides, there's a negative 2 there that's left over. So if you do that, then it becomes positive. And I get 29.89. So there's different ways to do this, but I think that's the easiest in the calculator. Subtract these over and then divide by this number right here. If you find something else that works for you, that's fine. Obviously, you can do this one step at a time, where you write that out as a number, write this out as a number, and subtract it over. So take your time if you need to, but it is a little bit more complicated to solve this equation for this one missing variable. Okay, the next problem says a pilot flies straight for 1 hour and 30 minutes. So that's straight like this way for an hour and 30 minutes, which would be 90 minutes. And then she makes a course direction. So she was going this direction. Now she changes directions and goes this way, which is 10 degrees right of her original course, and flies for 2 hours, which would be 120 minutes. She maintains a constant speed of 690 miles per hour. How far is she from her starting position? So we're looking for this distance here along this hypotenuse. And we can find these in terms of distances if we multiply by we have obviously distance equals rate times time, so we're going to multiply the rate times the time. The only problem is we have miles per hour and we're in minutes, so I do need to put things into hours. So let me change this 90 minutes to 1.5 hours. Let me change this 120 minutes to 2 hours, and then when I multiply by 690 miles per hour, the hours are going to cancel. I'm going to have a distance here, which gives me 1,035 and 1,380, and that's in miles. So now if I find the hypotenuse, I'll call this small c, and I'll call this angle c. If this is 10, this is 170 degrees right here, so I can just use the law of cosines on this. So I'll do c squared equals a squared plus b squared minus 2ab cosine of angle c. So you have 1,000. I'll plug this in for you. So there it is. And keep in mind, order doesn't matter. You can switch these two up, and it's not going to matter, and therefore these two. So it doesn't matter what you call A and B here, as long as they're both A or B. So then take the square root of both sides, and you can type this right into your calculator, and it gives 2,405.998 miles. Okay, the next question says if A equals 8, if B equals 3, and if C equals 10, find the measures of angles A, B, and C. Give your answer to at least 3 decimal places. So in this one, you want to first use a law of cosines. So I'm going to do c squared equals right here. and then go ahead and plug things in. The only thing you're going to be missing is this angle C right here, as you can tell. And then once again, I like to plug this in your calculator and just kind of do this by hand, but if you like to, do this one step at a time, then you'd subtract both these over, and then you divide by this number, which is -2 times 8 times 3, and that would equal the cosine of angle C. And then you would take the inverse cosine of this whole thing. So that's basically what you're doing in your calculator in order to get C right there, which gives 124.229. Now, I would, from here, use the law of sines because I think it's quicker. So now do the sine of like angle A, for example, over side A equals the sine of angle C, which is the 124.229, all over side C, which is 10. That way you only have one missing variable, which is A. And you remember solving these, so solve that for A, and about 41.4. And now you can take 180 minus these 2 in your calculator without rounding, and you get the last one, which is 14.36. Okay, the next problem gives us this. We have a pipe against the corner of an attic and a floor like this, where this is a 40-degree angle, and it wants us to find this distance here from the corner to where the point where the pipe touches the ground right here. All right, to do that, I'm going to look at this triangle right here. All right, now if you draw a line straight down, you might learn before that'd be a right angle, because this is a tangent line, and the distance from the center to a tangent line is always a right angle like that. So if you draw this, then you might remember that this would be half that. You've just drawn in an angle bisector, because another thing you learned in geometry was that if these points are equal distant, then that's the line that the angle bisector is on. So then you have basically a right triangle right here, where you can just do tangent of 20 degrees equals opposite over adjacent. Multiply both sides by x and divide both sides by tangent of 20, and that's what you're solving, which gives you about 16.48. Okay, the next problem gives us A is 60, B is 6, C is 9, and it wants us to find some missing things here. So it wants us to solve the triangle basically. So let's find A using the law of cosines. So I'm going to write that formula down in terms of A right here, and then I'm going to plug in. Get this right here. Now take the square root of both sides, and you get 7.937. So now we're going to look for another angle then. I'm just going to use the law of sines for that. So the sine of 60 over its opposite side equals the sine of B, which I'm looking for right here, over its opposite side. Now be careful when you're doing this, especially even in the last problem as well, because keep in mind there's two different triangles and the calculator doesn't know which one you're talking about. So in this one, I used this angle, which is an acute angle, and then I used this side, then this side. So I used angle, small side, big side. And there's only one triangle that can be formed with angle, small side, big side, because if you think about it, if you draw an acute angle here, all right, where you have, so this would be 6 and this would be 7. So I'm going to exaggerate it and draw it longer. I'll make it about 8, because it is about 8. In which case, there's only one triangle you can make, because you can't swing this side. If you swing this side down, it's too long, so it won't connect again. The issue that you run into is if it was the other way around. So let's say you guys use angle big side, small side, then I would draw the triangle like. So when you have an acute angle and then big side, small side, then you can make two triangles, because you could swing this side over here where it'd still be 6 and you'd have a completely different triangle. And the calculator doesn't know which triangle you want. So that's going to run into an issue. So if you do law of sines and you notice that you're using angle big side, small side, so had this side been bigger than this one, I would need to switch it and use different sides in order to make sure that I'm using angle small side, big side. So this is the one you want right there, angle small side, big side. So cross multiply and solve for B, and you get 40.89. And now just do 180 minus these two, and you get what's left over, which is 131.17. And it should make sense that my biggest angle is across from my biggest side here. I'm sorry, I used the wrong two angles. It's 180 minus 60 minus the B angle, and that gives you 79.11. Okay, the next problem says you're driving a plane at 100 miles per hour, and the wind's blowing this direction at 50 miles per hour. and it gives you a picture here that you can use. It wants to know alpha, so like basically the angle that the wind blows you off course, and then also then your relative ground speed if you calculate the wind into that. So we're going to use the law of cosines for that, which is, okay, so I'm just going to label these A, B, and C so I can use the equation just like this. Let me plug in. Actually, this doesn't work because I don't have the right information for this problem, 2 missing variables. So I'm going to use the law of sines first, which would be sine of alpha over its opposite side 50 equals the sine of 40 over its opposite side 100, and solve for alpha first. It gives you 18.75. Now once you have 18.75, you have your choice of law of sines and law of cosines now to find this side x right here. Because you have this angle, you have this angle, and you have these other two sides. So I'm just going to use law of sines. So I'll do the sine of 40 over its opposite side 100 equals the sine of the angle I just got, which is 18.75, divided by, I'm going to have to do 180 minus these two to get this angle up here, 121.25. And then I'll divide that by its opposite side, which is the side I'm looking for. Cross multiply and solve, and you get about 133. Now I don't know if it makes a difference, but I didn't round that. I kept that in my calculator. So things like that might help if you're not getting it right. Be careful with rounding, but that should give you about 133 here.